When installing a single-phase uninterruptible power supply, or UPS, operating at 208 volts, and its output lacks overcurrent protection but feeds a distribution panel with overcurrent protection in another room, the distance between the UPS and the overcurrent protective device is governed by the National Electrical Code, or NEC, specifically concerning feeder taps. The general rule dictates that the overcurrent protection should be located at the point where the feeder receives its supply. However, the NEC permits taps from feeders under certain conditions. The specific scenario described aligns with the feeder tap rule, allowing a limited distance between the UPS output and the overcurrent protection device, or OCP, located at the distribution panel. In this context, the feeder tap rule allows for a maximum distance of 10 feet between the tap point at the UPS output and the location of the overcurrent protection device in the distribution panel. This 10-foot limitation is applicable when the tap conductor's length does not exceed 10 feet and the tap conductors are suitably protected from physical damage. The ampacity of the tap conductors must also meet specific requirements. Firstly, the tap conductors must have an ampacity not less than the combined calculated loads on the circuit supplied by the tap conductors. Secondly, the ampacity must not be less than the rating of the overcurrent protection device terminated at the tap conductors. Thirdly, the tap conductors must not have an ampacity less than 1/3 of the rating of the overcurrent device protecting the feeder conductors from which they are tapped. This provision ensures that the tap conductors are appropriately sized to handle the anticipated load and provide adequate protection against overcurrent conditions. The 10-foot tap rule offers flexibility in situations where it is impractical to locate the overcurrent protection device immediately adjacent to the UPS output. For example, in existing installations or when retrofitting equipment, it may be more feasible to utilize the existing distribution panel with overcurrent protection located in a separate room. The 10-foot tap rule allows for this configuration, provided that all the stipulated conditions are met. In addition to the 10-foot tap rule, the NEC also recognizes a 25-foot tap rule, which allows for a longer tap length under more stringent conditions. To qualify for the 25-foot tap rule, firstly, the tap conductors must have an ampacity not less than 1/3 of the rating of the overcurrent device protecting the feeder conductors from which they are tapped. Secondly, the tap conductors must terminate in a single circuit breaker or a single set of fuses that will limit the load to the ampacity of the tap conductors. Thirdly, the tap conductors must be protected from physical damage and enclosed in a raceway. The 25-foot tap rule is typically employed in industrial settings or large commercial buildings where longer tap lengths are necessary to reach specific loads or equipment. It's crucial to ensure that all applicable requirements are met to maintain compliance with the NEC and ensure the safety of the electrical installation. Failure to comply with the feeder tap rules can result in dangerous conditions, including overheating, insulation failure, and potential fire hazards. Moreover, non-compliance with electrical codes can lead to legal liabilities and insurance issues. When determining the appropriate distance between the UPS output and the overcurrent protection device, it is essential to consider the specific characteristics of the installation and the requirements of the NEC. A qualified electrician should be consulted to ensure that the installation complies with all applicable codes and standards. This includes verifying the ampacity of the conductors, selecting the appropriate overcurrent protection devices, and ensuring that all equipment is properly grounded and bonded. In addition to the NEC requirements, manufacturers' instructions should also be followed when installing UPS systems and related equipment. The manufacturer's instructions may provide additional guidance on the placement of overcurrent protection devices and other safety considerations. It is also important to consider the environmental conditions in which the UPS system is installed. For example, if the UPS is located in a damp or corrosive environment, it may be necessary to provide additional protection to prevent damage to the equipment. Regular maintenance and inspection of the UPS system and related electrical components are crucial to ensure continued safe and reliable operation. This includes checking for loose connections, damaged wiring, and other signs of wear and tear. Any issues identified during inspection should be addressed promptly to prevent potential problems. The overcurrent protection device itself should be properly selected and sized to protect the UPS system and the connected loads. The overcurrent protection device should have an interrupting rating sufficient to handle the available fault current at the point of installation. The selection of the appropriate overcurrent protection device should be based on a thorough analysis of the electrical system and the characteristics of the connected loads. Coordination studies may be necessary to ensure that the overcurrent protection devices operate in a coordinated manner, minimizing the impact of faults and preventing unnecessary outages. Furthermore, it's crucial to consider the potential for future expansion or changes to the electrical system when designing the overcurrent protection scheme. The overcurrent protection devices should be selected to accommodate potential increases in load or changes in the system configuration. This may involve oversizing the overcurrent protection devices or providing spare capacity for future additions. In summary, when installing a single-phase 208-volt UPS without integral overcurrent protection, adhering to the NEC feeder tap rules is paramount. The maximum distance between the UPS output and the remote overcurrent protective device should not exceed 10 feet, provided all conditions related to conductor ampacity and physical protection are met. Consultation with a qualified electrician is highly recommended to ensure compliance and safety. Remember to consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. Electrical codes are subject to change, and it is essential to stay informed of the latest revisions. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific guidance on your particular installation. Proper overcurrent protection is crucial for the safety and reliability of electrical systems. By following the NEC requirements and adhering to industry best practices, you can ensure that your UPS system is properly protected and that the connected loads are not exposed to dangerous overcurrent conditions. Also remember that local codes can be more restrictive than the NEC, and it is your responsibility to know and adhere to these. Consider also the labeling of the electrical panel after installation of the new circuits in UPS. Be sure to accurately label each circuit breaker or fuse in the panel, indicating the equipment it serves. This labeling helps with troubleshooting and maintenance, and it also prevents accidental disconnections of critical equipment. Accurate labeling also assists first responders in the event of an emergency, allowing them to quickly identify and isolate circuits as needed. In addition to labeling the panel, it is also good practice to create a circuit directory that provides more detailed information about each circuit. This directory can include information such as the location of the equipment served, the load on the circuit, and any special instructions or precautions. The circuit directory should be kept in a readily accessible location, such as near the electrical panel. Regularly inspect the electrical system, including the UPS, the distribution panel, and all related wiring and connections. Look for any signs of damage, overheating, or corrosion. Pay particular attention to connections, as these are often the weakest points in an electrical system. Loose connections can cause arcing and overheating, which can lead to fires. Any issues identified during inspection should be addressed promptly by a qualified electrician. Keep the area around the electrical panel and the UPS clear of obstructions. Do not store flammable materials or other items that could pose a hazard in the vicinity of the electrical equipment. Ensure that there is adequate ventilation around the equipment to prevent overheating. Overheated equipment can malfunction or even catch fire. Consider installing surge protection devices at the electrical panel and at the UPS output. Surge protection devices can help to protect sensitive electronic equipment from damage caused by voltage surges or spikes. Voltage surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. Surge protection devices work by diverting excess voltage to ground, preventing it from reaching the protected equipment. Make sure to use a qualified electrician for all electrical work, including the installation of the UPS, the distribution panel, and any related wiring. Electrical work can be dangerous, and it should only be performed by someone who is properly trained and experienced. A qualified electrician will be able to ensure that the work is done safely and in accordance with all applicable codes and standards. Keep records of all electrical work performed on the system, including the date of the work, the name of the electrician, and a description of the work performed. These records can be useful for troubleshooting problems in the future, and they can also be helpful if you ever need to file an insurance claim. Develop an emergency plan in case of a power outage or other electrical emergency. The emergency plan should include procedures for shutting down equipment, contacting emergency services, and providing backup power. Make sure that all employees are familiar with the emergency plan and know what to do in the event of an emergency. Provide training to employees on electrical safety. The training should cover topics such as the hazards of electricity, how to identify electrical hazards, and how to work safely around electricity. Make sure that all employees who work around electricity are properly trained and understand the risks involved. When working on electrical equipment, always use proper personal protective equipment, including safety glasses, gloves, and insulated tools. Never work on live electrical equipment unless it is absolutely necessary. If you must work on live equipment, make sure to follow all safety procedures and use proper personal protective equipment. Be aware of the potential for arc flash when working on electrical equipment. Arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. Take precautions to prevent arc flash, such as wearing arc-rated clothing and using insulated tools. Regularly review and update the electrical safety program to ensure that it is effective and up to date. The electrical safety program should be reviewed at least annually, and it should be updated as needed to reflect changes in the electrical system or in the applicable codes and standards. By following these safety tips, you can help to prevent electrical accidents and injuries and keep your workplace safe. Understanding the specific requirements of the NEC related to feeder taps is crucial for ensuring a safe and compliant electrical installation.